done! We made it!
Guten Tag.
On this very hot day. If you are planning on finding out who's the winners, to all you folks over there, if you want to join us, please make your way to the stage. There is some sun coming in there. Don't blame you if you want to avoid those chairs. Feel free to stand around. Cool. Okay, how are you feeling after this wild weekend in Berlin, building on all these
tired.
cool... Yeah, who's tired? How are you feeling? You're feeling good?
Wow, so many hands.
All right, a couple people are tired. Who stayed overnight? Yeah, same people. Okay.
Congrats, guys.
Very nice. Okay, so 5th edition of the ZK Hack Hackathon in person. That's a wrap, folks. We made it. Yay.
Congrats, applause to you guys.
So this is a ZK focused IRL hackathon. We have over 45 projects built at ZK Hack Berlin. I put the fire because that's a lot of projects, but also because it's
really
super
hot.
I think that brings our number now up to like 190.
Almost 200, yeah, 190.
Almost 200, so that's very cool.
If you want to share, picture, experience, how it was for you over the weekend, feel free to do so on the socials. And we're gonna, say, I guess.
Yeah, I think we want to just say a big thank you to the partners who really came along. I think you see this at a hackathon. The partners they're not sponsors really, they're partners. They're bringing their DevRel team, they're working with the hackers. So yeah, big thank you to all of the partners. We're gonna read through.
Yeah, thank you to Irreducible. Yeah, I see them guys here. Thank you to Aleo team as well. So yeah, round of applause for them. Lee.
Yeah. We had our community sponsors, Boundless, Horizon, Aztec, ZK Passport, Highly, Arbitrum, Gnosis, Self, and Zion. Thank you, guys.
Thank you. Thank you, media partner, Zero Knowledge Podcast.
Hello.
Thank you, prize partner, ZKV.
Yeah.
We'll come back to the prize, of course, a bit later in this closing ceremony.
So here we are. We've made it to the end. The judging wrapped up around 3:30, I think, this time.
Okay, let's take.
We are now in the closing ceremony. We're going to be sharing the winners, and then we're going to be wrapping up. We're going to start, though, with the bounty winners. So if we could have actually someone from the Irreducible team who's going to share who won the based prizes, based bounties from Irreducible.
Thank you. I have a few slides. Hey, everybody. First of all, thank you all for coming here to Berlin to be part of this great event, and especially thank you all who were working on Binius. On the 3 bounties that we posted here, I'll go straight to it. What was the goal? We asked people, can you make things go fast? And we told you before you started working that performance engineering is fun. And we also told you that can you make Binius go faster on our CPU? So we got some learnings after the submissions. The first learning was that performance engineering is fun and hard, which makes sense. That's why we at Irreducible are doing this and not asking ChatGPT to do this for you, although we see that ChatGPT is getting better. There is another thing that we figured out, which is like, can you make Binius go faster? The answer is yes, but it's a bit hard to make it run 2 times faster, especially over the course of a weekend. Nevertheless, we had really good submissions, and I'm really happy for the teams who work on this. There were 3 bounties. The first one was the most interesting. I guess it has to do with money, but I want to believe it was the most interesting one. And we had 2 teams working on this problem. The best solution was by Roman, single-handedly. Congratulations, Roman. This was really good. Roman used gray ordering scheduling for univariate skip subcube evaluations. But he managed to push things by 13%, which somebody can judge as a low, but it's actually pretty good outcome of the exercise. And yes, we decided to accept that partially as a winning submission. The second one comes from the team called Checksum Warriors, Sean and Igor. Congratulations, guys. They took a different turn. They leveraged a low-level instruction set of Scalar extension for ARM, SVE2, and they basically rewrote certain parts of the code, different instruction, and got really nice 10%. Now, the good news is that 2 approaches could be combined, but it's TBD of how much performance we can squeeze further. So yeah, that gets us to the final call on the bounties. We are going to be granting each team for 1K for partial solution and thank you, teams, for great presentations that you gave us an hour or two earlier. Thank you so much.
Fantastic.
I guess no question at this point, so let's roll.
Thank you, Reddy.
Next up, we have Elio. Yes.
Hi, everyone. Thank you all for being here this weekend. It was really fun meeting everyone and, of course, building on Alio. We had a lot of project submissions, and we had 2 bounty tracks. We had one on best game built on Alio, and the other one, best DeFi app built on Alio. And for the first one, best anonymous game on Alio, it goes to Leo Mafia. Congrats. The team member are no longer here. I think they already left, but yeah, it was basically the rebuilding the Mafia game. You can play in a decentralized fashion. You can also chat live to figure out who was the killer. That was a really good project. So great job. Next one, best DeFi app. This was a hard decision. So the best DeFi app, the first one goes to Kinky Swap. It is swapping Alio and Aztec tokens, doing atomic swaps without a bridge. Really well done. The other one is the project built by Jordan called Pessimistic ZK Fair Liquidations. Congrats to both. The second one is a liquidation protocol that increases capital efficiency. So it's pessimistic because you basically assumes that you get liquidated immediately, and then the protocol will generate a ZK proof at the end of your trade. If you can prove that if you can prove that your sell price didn't go below the liquidation point, then you get your money back. Otherwise, otherwise you don't. So that was really great because it increases capital efficiency, and you can also hide your liquidation price so that other attackers can liquidate you. And we see a lot of business potential for that. That's it. Thank you.
Thank you. Cool.
Thank you, Christy.
We're going to read the bounties from our community sponsors. I guess we can start with Highly. The Highly team, I think, is or at least partially left already, but the prizes were for deploying an application on the Highly testnet. There were 2 winners, the ZK EMV for 1,000 and Highly Kebabulos. I don't know how to say that right.
Kebabulus.
Kebabulus for 1,000.
Kebab games.
Yeah, oh, kebab. I got it. Congrats.
Yeah, there's a joint bounty between Highly and Boundless, so that goes to ZK EMV for 1,000.
Well, very nice.
Very well
Lucky.
done, guys.
The Boundless, we don't actually have the results for the Boundless bounties, but they're going to be giving them soon.
I hope so.
We
We
hope.
were expecting that.
So
if you find Sasha, tell him to send us the
yes.
bounty
If you participate in that in the Boundless bounties, just get in touch with them potentially in our chats. ZK Passport had 2 winners. One was the private identity verification with Marriaged for 1,000. And the other one is also private identity verification with Well Key for 1,000.
Well done, guys. And then again, the joint bounty between Highly and ZK Passport goes to Fruit Swap for $1,000.
Congrats. That sounds familiar. Like Fruity Friends?
It
maybe?
looks much more serious.
Horizon had a bounty for the most innovative ZK app using Relayer, and the winner was Proof of Liquidity for 1,000. Congrats.
On the Arbitrum front, so we had 4 bounties. The best ZK app with product market fit goes to ZK Anti-Cheat for $1,000. Congrats. Woo. The best ZK app with no product market fit is for ZKML Good Blip, again for $1,000. Well done. Then 2 honorable projects are getting 500 each, zface.cash and ZK Shield. Congratulations.
Congrats, folks. For Aztec, we had a grand prize, Best Overall Aztec Testnet Project for Kinky Swap, 1,500. Congrats.
Congratulations.
Most innovative or technically proficient Aztec integration Anon proxies for 1,000. And Builder's Choint Grant, there's 2 of them. One is God's Hand for 250, and Dude, Where's My Flag for 250. That's a good name.
Congratulations, guys.
I like that.
On Zion side, so the best ZK app goes for Truth Seeker for $1,500. Congratulations. Runner-up is ZK Anti-Cheat. Congratulations again. And the runner-up consumer ZK app goes to Memento Mori for $500. Congratulations, all the projects.
Self had 2. The best self on-chain SDK integration went to Blind Match for 750 euros. And the best off-chain SDK integration went to Go Blow It for 250. Congrats, guys.
And that's it.
All right. I think, are we in the moment where we're going to announce the winners?
Yeah, I mean, I think that's what they're expecting. So.
Okay. Wow, we made it. So, as you know, we spent, from 1 to 2:30 meeting with all of you, the judges, those that wanted to apply for this track. We had an amazing group of judges. We're going to show them after. We did 2 rounds. So we broke up into groups. We saw your pitches. We then got together and kind of did another round. And we found our winners. Oh, yes. Prize partner, ZKV. Sorry.
I thought ZKV for giving up the price. Yeah, they were not expecting.
All right. So we start with Chewing Glass. Just to remind you, Chewing Glass is the prize that goes to the team that has maybe done the deepest integration, the deepest implementation, something where we could see this being used in the future. It's usually very technical, very difficult. Glass is chewed like the GIF. And the Chewing Glass winner for ZK Hack Berlin is a little bit of and on proxies.
Congratulations, guys.
2,500. Woo! Oh, and we now have our Hacker's Choice. Thank you all for voting. I think we just put it out. This is basically from the honorable mentions list. Everyone on that list is an honorable mention. You guys got to choose, and the Hacker's Choice for ZK Hack Berlin, Truth Seeker for 1,000.
Congratulations.
And now we have our countdown, starting with 3rd place. So this is the top 3. This is kind of what we spent a lot of time putting together. In 3rd place, actually, do you want to announce this one?
Why not?
All right.
It goes to God's Hand. Congratulations.
Congratulations.
Donation platform. I don't know where he is, but he's sitting somewhere. Congratulations for the great work.
2nd place for ZK Hack Berlin, we have ZK Anti-Cheat, who's come up a bunch of times in the bounties as well.
Very good work. Very impressive.
Very interesting one. Yeah. Anti-cheat software, but in ZK, helping it be private and sort of compressed.
And the grand winner of ZK Hack Berlin is
0 Hour.
Congratulations, guys. Our 2 winners here. It's quite an amazing job. And actually, I mean, you guys will get to know a bit more about this project now.
Yeah. Oh, well, here are the prizes, just to show. Oh,
they're all the champions. And now we will welcome them on stage. So starting with Chewing Glass, in the order we announced them.
Yes.
So please come on stage to present a bit more about your project, in 2-3 minutes, so that the audience can know a bit more.
We're actually going to do Chewing Glass and then the top 3, because Hacker's Choice just got picked in the last second. So, yeah.
Chewing Glass, 3, 2, 1.
Perfect.
Starting with Chewing Glass.
Do we have an adapter in case? Perfect.
I mean, do you have anything to show?
It's up to you. You could also just talk about it if you want to. Do you need an adapter, or you just want to talk about it? Okay. Okay.
Pretty clear. Hey, thank you very much. No, let's go.
No one wants to talk.
So what we were doing was implementing a protocol from 2 years ago on proxy signatures. So it allows you to delegate your signing power without revealing your private keys, and in a way that is undetectable. So neither the verifier nor any onlooker can know that the signature they receive was delegated. So once we implemented this, we thought, what can we do with this? We've implemented Aztec account contract that uses the signature as logic to authorize transactions. And so you can do, let's say, company, like a company card, for example, where you can delegate spending power. You could do like pocket money for your kids, or you can use this outside of like accounts.
I thought I would bring the diagram, but
Oh, that's fine. You can also use this outside, like for example, if you have a very small set of validators and one of them gets DOSed, or like a big part of them gets DOSed, your network might be down. But if these validators had previously sort of have little backups that they delegated to, they can come back online. And because it's anonymous, you don't, like no one knows whether or not we're using a backup or where the backup is. So that was kind of the project we've implemented in Rust, ArcWorks. We also have like WASM bindings if you want to plug it into a front end. And then we have a Noir verifier. Anything else, team? Sorry? Oh, there is a nice hash to field function in Aztec where it takes an array and adds it together. That's it. So
Like
you
the
can
hash
reorder the array
function
and get
is
the
like
same hash. So
Field addition. Yeah.
So yeah, be a bit careful. Oh, there's a video. Yeah, that is a bug. It has been reported, and I'm sure it's being fixed. Thank you.
thank you guys. Thank you very much. So next on stage, we will call God's Hand team. Yeah, you're up there.
Yeah.
Come here.
And I think we're going to just set you up. Do you have HDMI? We don't have time. You got to go now, so we could even just put your DevFolio thing up. It's just a few minutes to describe the project. Do you have something to show? Okay, perfect. I think that's your chat, though. If you want to show that. So I like. Cool. Do you want a mic?
Um, Hello all. So I built God's Hand, a solution for a multi-agent system which listens for global human disasters and creates walls on Aztec so that people can donate anonymously and privately. And I'd like to talk to you about how I built this product. So initially, I wanted to build a system where I could donate on EVM, but and then I switched the system where the users directly donate their funds on Aztec. So here's how it works. The users, the agent scrapes for disasters that happen around the world, find a disaster and post it on Aztec, and then people can start donating to it anonymously by posting the disaster hash, the amount, and once there's money inside the pool, any organizations like Red Cross can perform KYB and apply for funding. And the agent is again going to check if the organization performed whatever they promised, and it's going to unlock certain money in Aztec. And now the people can vote using ZK Passport. They can prove that they're prove that they're unique human and also anonymous by verifying their proof on Aztec. So I'm going to show you a demo on how this is going to work. So I wipe coded all of this. So it looks all right. So here you could see, yeah. So here you could see all of these disasters that's been happening around the world. We specifically targeted around India. So I made the AI search disasters that happen across India. And we also took WeatherXM data where all of these, for India, we took the data from Bengaluru, especially where there were a lot of nodes present. So all of these data is being fed to the AI. And based on this, the AI takes a decision. So the AI agent runs on a TEE. And here you can see the logs of the agent. So yeah, so here it has made an observation. It took weather information about a place where disaster is happening. So first step, it searches for disasters are happening, and then after it gets a latitude and longitude, it finds the environment data, and then it does an analysis based on the news and other sources. And after after it receives a complete response, it returns back and posts a tweet on X. And yeah, so here we have a disaster. And as a user, I can donate to a disaster now. So ideally, I would want to integrate MetaMask where I can donate directly from an EVM, but now I'm going to use an Aztec wallet. So I have 3 Aztec wallets stored in my browser. So I'm going to use one of them. Yes. So now here I'm going to choose 0.008, and I'm going to click donate. And here you could see that the transaction is sent in the local sandbox. So everything is run on local sandbox and not on the testnet. And yeah, we have the transaction hash. And once there are enough donations, an NGO can request for money. And I'm gonna upload a logo. So I as an NGO would get some basic information about what I did, so that I'm letting the AI know that I did a certain kind of specific help in a specific region of people around the world. And the AI is going to analyze it. Okay, so I ran with an issue here. My Cloudflare ran out of credits, and sorry about that. So that's what I was trying to delay my pitch. So yeah. Thank you.
Thank you very much. At least it was working earlier. We saw it. So now I will ask on stage the team who came number 2. So yeah, ZK Anti-Cheat. Yes. Please come show us what you've cooked. You get some, yeah, okay.
Kind of. Do you have a perfect. Oh, it's taped.
So basically, if you're not familiar with anti-cheat engines, every time you download an online game that's competitive, they download some spyware into your kernel, and it just takes your data, sends it to a server, does some analysis, and you have to just trust them that they're doing the correct thing, and you have to trust that they have the correct judgment. You don't have any feedback from them. You don't have any way of verifying what they're doing, which is effectively spyware. I don't think anyone here would accept that happening on their system. So what started this research is basically, if anyone is familiar with the Call of Duty hack that happened recently, where someone was just sending other players in the direct messages some string of a popular hack, and they were getting banned on stream. And there was actually no way of validating what happened, and they just stayed banned for a couple of months until the hacker came out and said, hey, actually I did that, I trolled them, and I'm the one who banned them. So effectively what I did is that instead of just saying, okay, rewrite your game, run it as EKVM and take the proof, and no one is going to do that. It's totally hard. So I made a universal solution, which is basically we take the memory state of the game that you're running, and we compare that against what is intended to be running with a Merkle tree. So we calculate the Merkle tree, and there are some branches that are always static. In most games, 90% of the state is the same. It's just the textures, it's just the map, just only like a small chunk is changing. So we only make one proof at the startup. We make the Merkle tree, we send it to a server. The server creates a proof and publishes it on chain. A server can be an MPC or whatever you wish it to be in the future. You take this proof, and it's a proof of inclusion that you have the correct branches inside your Merkle tree. Afterwards, if you have something bad, we make a proof of inclusion of the bad hash and we publish it on chain, so anyone can just verify that why they got banned, what's the reason behind the ban. So we have one final issue, which is if I play for 2 hours, I'm not gonna just go through like I don't know how many, like 1,000 proofs and verify them. So we just leverage recursive proofs, which compact all the proofs into one. So I have one proof that verifies that the entire duration, which is like 2 hours, 3 hours of my gameplay, was correct. This is really good for esports when someone claims they're using a popular hack or a popular tool to prove that they're doing the correct thing. One example I tried is like in Minecraft, we have the X-ray cheat, which changes the textures to make it like a wall hack. I can see where are the things I should go to. So it just makes everything easy, especially for speedrunners. So if we look into the memory, we can see there are some special fragments of that. The official textures are just switched with something like that. So it's very easy to detect it, and we can make a proof of that really quickly, thanks to Noir. So where is this actually important is that we don't sacrifice on performance because the proof generation is done on the server side, and we actually hide our data thanks to Merkle trees. And the other thing is that I can just have one proof of my entire duration. Whereas this actually would be really, really good as a solution would be for speedrunning, because a lot of like people claim they're hacking, or most of them are actually hacking, and the only proof to do it is just a live stream on YouTube that they're playing correctly. So having a proof is really important. Where this can actually go in production right now is simply just going to, this is what I want to do in the future, which is, I don't know if I can click. So to have a scoreboard for competitive gamers who do speedrunning, and they have proofs on chain that verifies they were running exactly the game they intend. This is really good for games like Super Mario because the memory is small, and they can just verify correctly exactly what's happening. And there's a lot of research onto that, so it's not really hard to do it for now. And for example, we can showcase like my mouse is not working, so but I can expand it in here and see like it's invalid. For example, if I will show you like how it would work in production. So the player would be like, this is just Minecraft, he's playing correctly, and there's a proof of on chain that it's correct, the correct thing is running. And then afterwards, let's say he decides to open a cheat and open it. So he will run it. And if it closes down, and there's a proof on chain that verifies that there's a certain hack in there. That's what, like, it's not just something that's, you can't like, you actually have transparency in there for what's the reason. And that's about it. Thank you guys.
Well done, congratulations. A very actually useful use case for ZK, I guess. Now we will ask the winning team to come on stage. Yes, that's you.
So we're just going to show a quick set of slides, the same we presented earlier, and then the quick demo. So the idea of the project was to push for extreme client-side ZK proofs. And what we did was a custom ZK proof system that runs and generates proofs on a Pine Time, which is an open source smartwatch that has 64K of RAM. So the idea of the use case here is that I can prove that I walked more than 10,000 steps every day this month, and then my health insurance is going to give me a bunch of money back, hopefully. So this was somewhat inspired by Google's latest client-side proving thing from a few weeks ago, where you can prove that you're older than 18, I guess, on your phone. But that's too easy. We wanted to do something more complicated and see if it works. So that's why we picked the Pine Time. So it's this watch over here. You'll know at the end why it has a black screen. So it has this nice chip which has some crypto operations like curves and hashing, 64K RAM. It has a couple megabytes of storage. So if you really want to, you can put some optimizations in the ROM and do some crazier stuff. But yeah, and 64 RAM in total. It also has an operating system, a bunch of other apps running and stuff. And it has metrics like heart rate, steps tracking, and different things. And
yeah, so 64 kilobytes of RAM is enough to store 2,000 hashes and 1,000 elliptic curve points. So we didn't even start trying to use an off-the-shelf proving system to run on this watch. So we had to do some manual engineering, and we went with some Sigma protocols. So basically, what we're trying to prove is a range proof, right? So from the watch, we get a number, which is the number of steps. We want to show that it's above a certain threshold. So we subtract that threshold and then range proof the result of this. And this is basically done by committing to the bits and then in a hiding way using Peterson commitments, and then proving in zero knowledge that the committed value is either 0 or 1, but nothing else. Right, and then out of this you get a proof like this. So you can see it's a bunch of curve points and a bunch of field elements, and you can copy-paste that into a Python script and then it verifies.
So this solves one part of the puzzle. If you want to have this type of proofs on your smartwatch, wearable, whatever, there's other problems you could have. So these are not things we're trying to solve here. We're trying to solve more from a research engineering perspective. And so this is basically what we managed to get done. So there was design of the proof system and then implementing all of it in embedded C++ on a real-time operating system using this TinyCrypt library, which is from Intel. The operating system is called Infinite Time, which is a variant of the free RTOS operating system for embedded devices. Emulate integration for testing, user apps to just trigger the proofs. We have the reference Python prover to make sure that whatever is happening in the watch is actually correct. And the Python verifier, no need to have a verifier in the watch itself. And everything works in the emulator. So the things we didn't manage, so we basically ran out of time and out of brain. So we actually wanted to flash the firmware. So we used the source code of the operating system. So we have the firmware, it is compiled, it can run everything. But of course, we wanted to flash it on the watch to actually walk around and have a super sick demo. But yeah, we bricked it at 4 in the morning and then all hope was lost. I think it will survive, but probably need time to save it. It's pretty dead right now. The other thing we wanted to do, and also ran out of time, is Bluetooth communication to a verifier phone or a laptop for a nice end-to-end pipeline, which, yeah, just ran out of time. So I'll run a quick. This is what the screen of the watch would look like if you were looking at the watch. Not this part, this is just debugging. So we go to our app, and this is the largest I can make it. If I make it full screen, it doesn't work anymore. So this is our app, and then, yeah, we didn't walk much. If you try to make a proof, we've got to walk more. So we walk a bunch of steps. So in the demo, we have 1,000, because otherwise we have to get to 10,000, and then the whole thing might crash. So. And then now we can try to make a proof. Yeah, we got the proof. At least the UI says so. But yeah, we can also take the proof here, which comes from emulator. This is all the proofs for all the bits. And this goes into the Python verifier and then verifies that the proof is correct, hopefully. That's it. Thank you.
Well done, guys. Congratulations. Yeah, don't do crazy thing at 4 a.m., I guess.
Hey, just before you get off the stage, by the way, folks. We have a few little bonus gifts for you. We have some ZK Hack water bottles.
Yeah.
For the winners.
For you.
We also have I think we have 2 more. So we have
And the other, it does one for you.
Exactly, for all 3 first prizes. And we also have some ZK podcast branded ledgers for you guys. So these will be nice. I hope that doesn't break for you. And I'll give that to the rest of the winners as well just after. These are some bonuses we found in our swag container. And we're like, let's give it. Yeah. Wow. Amazing. So I want to say a mega thanks to the judges who came through. Judging this is always an incredible challenge. There were so many good projects. As you saw, there was, I think, 12 honorable mentions. There was a ton of teams we also wanted to include on that. It was very, very hard to do. So big thank you to all of the judges for spending the time with us this afternoon, for watching the pitches, for spending time trying to gauge it. Thank you so much.
Thank you. That's all of them, yeah? Yes, that's all of them.
Thank you to all the volunteers who helped out for this whole weekend. Thank you.
Thank you guys.
Thank you to the W3 Hub for hosting us at this venue. It was very warm, but I think we made the best of it, and I think they were amazing to work with. So thank you guys so much. Yeah, thanks to the AV crew. Henrik back there, thank you.
That's true, Henrik, yes.
And obviously, thanks to all of you, to the hackers, for coming out, for spending the weekend with us, for joining our 5th edition, and for building these amazing things.
Well done, everyone.
Cheers.
Thank you very much, hackers.
So this is the team that put the event together. I think the core was Quentin, Agni, and myself, running for the last 3, 4, 5, 6 months. I think this has been a long time coming. We have the team, like other parts of the team, Rachel, who's doing a lot of that billing, Natalia, Hanya, helping out here, and then Gaylord as the host. I do want to just do, really, Quentin, Agni, thank you for putting this together. We just did 2 major events together in a row.
Another successful event.
Yeah. Also, Agni is an amazing events person in general, and we've just done 2 intense events, so we're going to take a bit of a break in our events. So if you are looking for someone to work with on events, she's there.
Yeah, you should.
She's the best. Cool. Okay, so I want to say a big thank you to all the sponsors once again. Thank you guys for coming through. As I said in the sort of intro, there was a lot of competition. There's a lot of other events. You chose to work with us. We really appreciate it. Thank you so much. I think that's it, right? Yeah. Follow us forever on Discord. We have got you there now. Stick around.
Don't leave.
We do other things over on the Discord. There's sometimes study groups. We're going to be having a whiteboard session. We're launching season 3 of whiteboard sessions in September. So stay tuned for that. That'll all be happening over on ZK Hack. Yeah. Is that the end?
Yes, it is.
Wow, I think we have one last. Thanks for joining us, folks. Woohoo! What? Yeah, we got that. So we found out about this heat wave 3 days before the event. I'm really glad we were able to get those popsicles. There's a couple left. Please finish them. We have to give that freezer back. So yeah. And there's some popcorn as well. So just if there's any snacks or anything, please do grab it before you go. Thank you.
Thank you all.
Bye.
Thanks.